Hi everyone and welcome back to this brand new video from make.print.repeat. In today's video we'll do part 2 of the Fusion 360 Zero to Hero series. To have success in CAD as we have previously seen, I think you have to have a clear idea, practice, and just mess around. But in today's video we will focus on how you will make an actual part. So let's start with the basics. To create a part, the main ways to make it are CNC machining, SLS, FDM, lathes and SLA. All of these ones are the main manufacturing techniques that I would expect a maker to have access to. However, there are better manufacturing ways if you're planning to mass produce. So for FDM, this is your standard Prusa or Bambu Lab, and it just has a layer by layer way of making a part, and the main constraint is just that you can't print with an angle that's less than 30 degrees. Then we have CNC machining, where the main constraints are related to the tool, since in CNC machining you are removing material instead of adding material, and therefore it's very hard to make text, undercuts, 3D surfaces, and also fillets. It's also important to know that in CNC machining you can't create a perfectly square corner, since the tool is a drill bit and it's circular. Then we have SLS, which is just melting some very fine powder with a laser, and this allows you to print many objects without thinking about support material. Let's just take a second to thank this video sponsor, PCBWay, which can also help your projects become a reality by producing both high quality PCBs with low cost that have many options, including assembly service and SMD stencil, but most importantly they offer CNC machining, both 3-axis and 5-axis, and 3D printing. CNC machining is available in a variety of materials from metals to plastics, and 3D printing with many technologies like FDM and SLA, but we'll look into this later. But now let's just mess around. However, before actually getting into the CAD, let's get some ideas. So if we search for Dream Coaster, we see some designs, and most of them are just a flat cylinder with a small lid to prevent the glass from sliding around. But now let's see some metal ones. Most of them look pretty boring, but maybe we can find one that's more interesting. Oh, like this one here, which has a nice pattern on it. Okay, now that we have some main ideas, let's get into the CAD. Remember to always save your file. This has saved me many times. So first let's start by just creating a sketch. And in this case, since we're revolving a part, let's make it in the Z plane. Now imagine that you're trying to revolve a cylinder. To do that, you just take a rectangle and then revolve it around one of its hands. So now let's just make a rectangle with some dimensions, and then let's add that small lip at the hand. In this case, I'm just approximating dimensions, but since it's a part with no functional constraints, you can just guess them. And now let's get the revolve feature. Select the sketched parts and then just select the axis, which in this case is just the Z plane. And now we have a pretty nice cylinder to start with. Okay, so now let's add a logo, maybe the open source logo, since it's pretty important in the 3D printing community. In this case, to import a canvas into Fusion 360, I would highly recommend to make it without a background. So in this case, I'm just using an online tool to remove the background. Then you can just import it, select a plane. In this case, it's just the top plane, and then we can move the canvas and also scale it. So maybe let's try to center it a bit, and then let's make it a bit smaller. That looks good. Now we have to make a sketch and actually trace the canvas. If this was an SVG file, we could have just extruded directly the SVG file, but in many cases the SVG files are not very clean, so it's much better to just import a canvas and then trace it over. So let's make two circles, which are the boundaries for the logo, then another circle which is just the final boundary, and then we make two lines for the gears. As we see in this part, there is some symmetry and also some rotational symmetry. So whenever you're trying to trace a logo or trace a canvas in general, you should try to use the symmetries of the part. This just makes your traced part much more similar to the original one. You can always try to free draw it, but it will never look as good. So in this case, we can mirror this line here, since it will be the same on the other side. So just select the mirror tool, and the origin as the axis. And then we see that there is rotational symmetry for the gears. So we just select the two lines, a center point. And then in this case, I see that there are, I think, 7 gears, but it's not full, it's partial, so you have to select an angle. In this case, might be 300, maybe 270. You just guess until you find one, honestly. Yeah, I think in this case it might be 270, yeah. At 270 they line up, so we just have to then move the thing on the other side. And now that's done. So the logo is made. Now that we made the logo, we can just finish the sketch and then click on E for extrude. Then just select the sketch and then the outer plane to just cut. And now we're done. But let's make this a bit more interesting, maybe with a pattern. Hexagons are really nice for this, they look great, and as we will see, some people think that hexagons are the bestagons. There is actually a very nice video from CGPWay that explains how hexagons are the bestagons. I mean, there are bees, and they think that the hexagon is just the most efficient way to pack honey. And then, honestly, apart from all of these, hexagons just look nice. So let's just go with the hexagons. To make a nice hexagon pattern, I would suggest to divide it into steps. First, prepare the plane on which you will make the pattern. So create an offset on each of the boundaries and then just leave that for later. Then create another sketch, and this will be the sketch that actually contains the hexagons. So as before, create some offsets, then a polygon, and then just select a dimension. In this case, it's not really important, but just select one that looks nice. Then make a vertical line, a horizontal line, and also a line which connects to the midpoint of the first side. And we will use these lines as the guides for the rectangular pattern. So just select the 6 sketches, and then actually it's better to first modify the hexagon rather than after, since after we will need to modify many more instances. So for CNC machining, remember that you can't have sharp corners, so just remember to apply some fillets on the sides. Now that that's done, let's actually select the lines and then just the directions. I always recommend to use spacing instead of accent. Then just do symmetric and find a distance which looks right to you. In my experience, it's always about double the size of the hexagon. Then just make the pattern big enough so that it fits on the entire sketch plane. Then extrude what we made before, keeping that offset. And then just select the sketch and then extrude the things between the hexagon. And this is the fastest way to make a hexagon pattern. And as you see, it looks pretty nice. It's not perfect. We have to fix some small imperfections, but that's quite easy to do. Let's just go back into the extrude tool and select this, and yeah, that looks nice. Maybe also that top one. Obviously, when making patterns there is some cleanup, but it's pretty nice. Now we have 2 ways to make this more CNC machinable. One is just a tedious way where you select all of the corners and then just apply fillets to them. This takes quite a long time, but it's pretty straightforward. Also remember to make the fillets always of the same size. And now that's done, and this is ready to be CNC machined. Yeah, it looks very nice. It will be quite heavy, but now we have V2. In V2 it's longer since we have to go back to the initial sketch and think more about how we actually made the hexagon. So in this case we can just modify how we extruded it. So let's just extrude the center circle and then the first gear. Then let's just apply fillets to these few edges. And let's keep them as 1 millimeter fillets, and then let's just do a circular pattern with the fillets. Select faces and then just select the faces that you want to pattern. In this case, just select the ones for the gear. Then select the center, and as before, just do a partial one, 270 degrees with 7 instances. And now that's done. It might take a bit more time, but it's probably more fun to do. Even though this still leaves us with some issues to deal with, like now we have to fix a bit the sketch, since it might get fucked up. Apart from that, it looks pretty good. We go on and then just fix if there are any other issues, but it seems okay. And at this point, unfortunately, we still have to select the outer ones, since you can't really apply a fillet to a pattern before that you make the pattern. So now we have to just do it for these outer ones that intersect between the pattern and the actual open source logo. Also, a tip: when trying to select an edge, Fusion usually allows you to select it even if you don't see it. You can just try to hover it, and it usually assumes the one that you want to do. Now let's repeat the same step for the other side. And then we're done. Now we can just select the body, then save as mesh, and in this case we can save it as a 3mf file if we want to 3D print it. But since we want to machine it, it's probably better to save it as a step file. So just go on to export of the main part, select step, and that's done. So now let's explore how to make it if you don't have access to a CNC machine or a 3D printer. And you can do it with today's sponsor, PCBWay. They offer great PCB prototypes, but also CNC and 3D printing. For the PCBs, they have a lot of options, which make it very easy to make a very nice PCB, also for a great price. But apart from that, let's look into the CNC machining services. You just drag the file, and it automatically loads it, and it will give you a quote depending the material that you choose. So first let's select the quantity, and as you can see, the more you buy, the more the price decreases. And they have so many materials to choose from metals to plastics like PEEK, bakelite, and also carbon fiber. And then you can also choose the surface finish for the metals. But if you prefer to 3D print, you can always just select the 3D printing option, and then it's obviously much cheaper. The resin is SLA 3D printing, the nylon is SLS, which is more expensive but stronger. And then you can also 3D print metal if you really want to be fancy. With 3D printed metal, it's not quite as strong as CNC machined, but it gives you a lot more freedom in what you can create.